Set complement is the set that contains all the elements in the universal set but do not belong in the set A. So these elements are in the universal set but they are not in the set A, and we write it as A complement or A prime or A to power C, which both mean A complement. And now the definition is, this is a set X such that X is contained in the universal set U and X is not contained in set A. If we are to draw a Venn diagram to see what that means, this other part of the box we said represents the universal set, and we have our set A here. So we have a set A. These elements belong in the universal set but they are not in A, and that's what we call A complement. Let's see an example, and in most cases we'll be given this universal set because a set has to be defined. We have an example. You are told if the universal set is equals to, we have a set of numbers from 1 up to 9 as our universal set, 6, 7, 8, 9, 10. Let's just put it up to 10. And then we have our set A. Set A has elements 1, 3, 5, 7, 9, 10. Find A complement. We are saying these sets are in the universal set but they are not in A. So meaning 1 is not part, because 1 is both in A and in the universal set, but you can see that 2 is in the universal set but not in A. And then our next element will be 4, and then 6, and then 8, because we are interested in the elements that are not in A but are in U. That is the complement. Our next operation is the set difference, and a set difference is the set that contains all the elements of one set that do not belong to the other set. That is, for instance, we have A minus B. That is the set difference of A and B will be the set that contains the elements in set A that do not belong to set B. For instance, if you are writing, we will have A minus B will be a set X such that X is in A and X is not in B, and X is not contained in B. If we are having B minus A, we are going to have X is contained in B and X is not contained in A. If we're going to draw the Venn diagrams so that we will be able to see what happens, we're going to have our first, which is A minus B. We have two sets A, we have another set B. This is set A, this is set B, and we want to represent the difference between A and B. These are elements in A that are not in B, meaning we are shading elements that are strictly in A. On the other side, we have B minus A. These are elements that are strictly in B, but these elements are not in A. We're going to have B minus A. This is our A and this is our B. This means that these elements are strictly in B, set B. So we are going to shade strictly. We're not shading the intersection between this represents both sets that are both in A and B. So we are just going to shade this other part strictly. That is B minus A. An example. And you know A minus B, another thing to note, A minus B is not necessarily equal to B minus A. They might not be equal. So let's see an example to prove that. Example, we are given set A is equals to A, B, Y, X, E, F. And now we are given set B, C, U, X, W, E. We want to find A minus B, which is equals to elements in A that are not in B. We're going to have A, B, Y, A, B, Y, and F. What about B minus A? These are elements in B that are not in A. We have C, U, and W. You can see A minus B is not equal to B minus A. That is the set difference. And then lastly, we have our symmetric difference. Symmetric difference. Which is quite simple to define. Symmetric difference, A, we are using this square, is usually we have A minus B union B minus A. Gives us the symmetric difference. That gives us the symmetric difference, meaning this consists of elements that are in A but not in B, or elements that are in B but not in A. That is quite interesting. If we have to draw, let's just draw this thing to help you see. We have two sets, A and set B. We know A minus B only covers this, and B minus A only covers the other part. So that means we are going to have this intersection has no elements. Now that's how we draw the set, the Venn diagram of the symmetric difference. Let's use a practical example. So meaning, for you to get a symmetric difference, you must know how to compute the set difference. Using our previous example, we have an example. We were given A to be equals to A B, Y, X, E, F, and we are given set B to be equal to C, U, X, W, E. We went ahead and got A minus B sets in A that are not in B. We had A, B, Y, F. We went ahead, we had B minus A sets in B, elements in B that are not in A. We had C, W, U. That means that our symmetric difference is the union of these two. Remember what the union means? All the elements in A and B, B minus A. So our union will be the set of A, B, Y, F, C, W, and U, and that is the symmetric difference.